Good morning, geometry. Once again, I want to put up another example of how to use the law of cosines in conjunction with the law of sines to find the measure of the sides or the angles of a triangle. And there's a couple of things that I want to add to this morning's law of sines, law of cosines video. So here we go. Okay, so once again, the law of cosines found on page 512 of your textbook comes in three different varieties. And there they are again. Please note the pattern. Notice that you've got an a squared is equal to b squared plus c squared, and then here are the b and the c, and then the cosine of the angle opposite the side you're trying to find. And that's the same case with the b and the c. And I pointed out, and here's your triangle. Now what I did is I changed this a little bit. And there's a couple things I feel I must add. This does not have to be a right triangle. In fact, if you're using the law of cosines to find this stuff and you've got a right triangle, well, you're doing a lot of extra work. You should just use the Pythagorean theorem. And then the sum of the angles, the sum of the interior angles of a triangle equal 180, and you'll be done. But anyway, in this case, I changed things around a little bit. Now we know the measure of angle A. We know the measure of side C, the side opposite of angle C. And we also know the length of B, the side opposite of angle B. So this time we're looking for A. If we're looking for A, we're going to choose that one. A squared is equal to. So here we go. So there's my formula I'm going to use to find this. A squared is equal to B squared plus C squared minus 2AC cosine of the angle of A. So if I plug these values in, notice that a squared is equal to 16 squared plus 20 squared minus 2 times 16 times 20 times the cosine of 64. Now, let's make sure we understand how we got this. That's what I need. This is what I have. I have this and I have this. Notice it fits the side angle side. If you have side angle side, you should be using the law of cosines, and of course, if you don't have a right triangle. All right, so that's where I got that. That's where I found C. That's where I found B. That's where I found the measure of angle A. So if I plug these in, looks like that. A squared is equal to 256 plus 400 minus 640. Now the cosine of a 64-degree angle is 0.4384. On your calculator, hit cosine 64. Poof, there it is. Plug all this stuff in here and you will find that a squared is equal to 375.44. Now take the square root of that, and a, the length of that side, will equal 19.38. So a, right here, we'll put in 19.38. Let's do that. So right here, I have 19.38. That's what a is equal to. Now, remember, triangle's got 6 pieces. I have 4 of them. I know the measure of one angle, and I have the measure of all 3 sides. All right. Remember, next, we need the measure of angle B or C. Doesn't really matter. I chose B because I get to use the piece that we just found. So anyway, and here's the law of sines again. Remember, it's the length of A over the sine of A is equal to the length of B over the sine of B is equal to the length of C over the sine of C. Or you can turn it all upside down, matters not. Be consistent. All right, so here we go. So 20 over sine C is equal to 19.38 over the sine of my angle A, which angle A is 64 degrees. So anyway, I set that up. The sine of a 64, to find that, your calculator, punch the sine key, 64, enter. That's what you should see. And then you plug that in. I do a little cross product, a little algebra. Now, when you get to this point right here, this is where you're trying to find the measure of an angle. You know the length of the sides. Remember, if you know the length of the sides, you need the measure of the angle, you've got to use the inverse key. So in this case, hit the second key, then sine. And you'll actually see that. You'll see that sine -1 pop up. And then put this in there. Now make sure that your calculator understands order of operation. I had to put all the parentheses in there just like that. And you hit enter, And the measure of angle C, 68.06 degrees. And there we go. So if I put that in here, I will put in 68.06. And I'll bet that angle, finding that, is not even a challenge. 180 minus this, minus that, that'll go right there. And you'll have all 6 pieces. All right, that's all I got for that one. More to follow.